So thanks for having me here. It's always exciting to talk to folks that care about development, but also operations. And what I'd like to do today is spend a few minutes talking about something I've become quite interested in over the last year and a half, which is operations. Not just because operations is interesting. It's actually, it can be fascinating. There's a deep science to approaches to operations to really drive organizational efficiency, and there's a lot of things to geek on. But also just as a way to remove some of the toil and unpleasantness from life. You know, sometimes operations can be a burden. And what I'd like to do today is contextualize some thinking around new ways to imagine operations as a business, as a developer, as an organization. And I'd like to snap those to Kubernetes. You know, Kubernetes is a technology that we built inside Google a couple years back. It's become pretty popular. How many of you are using it right now or have played with it? All right, great. How many of you are using Docker right now? I'm just trying to do the mental intersections. Pretty close intersection these days, which is kind of cool to see. And so what I'd like to do is just walk through this perspective of a new way of thinking about operations, Kubernetes, and how some of the Kubernetes concepts apply back to that, and we'll see where this takes us. So, let me turn on my little clicky thing here. Apparently, I'm not doing as well as I thought. All right, here we go. So, why focus on ops? Toil is the enemy of speed. At the end of the day, you are a developer. You want to create code. You want to get that code into production. You want to service your customers. You want to go as quickly as possible. Every point of friction is holding you back. Every point of friction is stopping your business from being successful. This is, you know, it's really important to kind of get into this mindset, like just drive the toil out of day-to-day work. The second piece of this is change is stressful. Like at the end of the day, almost every outage you see results from some kind of change. You know, it could be a simple configuration change that brought down the entire S3 region. Or it could be some nuanced bug that you've introduced into your code. And you're never going to know. And you're never going to know whether the breakage is as a result of something you did or something you didn't do properly, if there's a lot of manual interactions with the systems that are running your production world. And so getting the stress out of change is kind of critical. And at the end of the day, as developers, you may have to carry a pager. I don't know if anyone loves carrying a pager. I don't think most people do, but if you do have to carry a pager, it's a lot better to not get paged. It's a lot better to live in a world where your systems are somewhat autonomous. They can actually be relied on to bring things back into a coherent state. And all of this is embodied inside the world of Kubernetes. And so the way I've come to think about this is along this line of we call it cloud native. And cloud native is a very nebulous term. When we kind of picked it, it really didn't mean anything. I've always been a believer in just picking a name that kind of you can create a narrative around. But at the heart of it, when you think about cloud native technologies, it's really about doing what we did with cloud. If you think about cloud, it's take a technology, combine it with an operations team, put it behind a provisioning API, make it available on demand, right? So as we start thinking about this new world of cloud native operations, it's really about moving from a world where you're delivering and taking a piece of technology and throwing it over the wall at the business or creating a static artifact that runs to this idea of living with the technology as a service, delivering technology that is a living thing that changes and evolves at the same pace of your business. So that's the first point of order associated with this. The next point of order is, when you think about it, what you end up doing is going from a world where when you need something, when you need a dependency, when someone wants something from you, it's no longer a ticket-based operation. You can move to this world where provisioning happens at the back end of an API. You think about the world of cloud with Amazon, you don't have to file a ticket to get a VM. You just make an API call or interact with a tool. And so much of our world could be evolved in this way. And by moving to API-driven operations instead of ticket-driven operations, we just pull toil out. Everything gets to go quicker, and things become much more predictable. And the other thing that I think is important to think about here is starting to, as you embrace this idea of service, you need to start thinking about service level. Like, what am I trying to accomplish? At the end of the day, if you want to achieve almost perfect SLA, the best thing you can do is just stop updating anything. Just lock it down. Never change it, right? If you do that, it probably isn't going to break until you reach the sort of end of the life cycle of the hardware or some other weird event happens. But at the end of the day, managing to an SLA, thinking about an SLA as this gating factor that enables you to achieve a certain level of velocity, but also deliver a quality of service as necessary, that becomes a fine balancing act. And so I think about this operations world largely as an SLA optimization problem. You want to go as quickly as you can. You want to get as much code into production. You want to get the changes as quickly into production and minimize the time that exists between a customer needing something and you being able to deliver it in code with some constraints. You know, the one constraint is you need to have the system stay up. You can't have it going down all the time, obviously, otherwise you go out of business. But you may also have some regulatory constraints or some other security constraints that are difficult to fully internalize, but you know that you have to follow policy and just paint within the lines. Otherwise, bad things are going to happen. And so to get to this world where you can start to think about this balanced engagement where you're pushing as quickly as you can, you're moving as fast as you can, you're holding back when you start to see the seams show, when you start to see issues with your availability, it requires a very new way of thinking about operations, this kind of cloud-native mentality. And the bastion of this, the heart of this, the place that I've seen this work the best is grounded around this new individual, this new operator, the SRE. How many of you have sort of read the SRE handbook? Awesome. So the SRE is an engineer. It's a badass engineer. It's like a serious engineer. But it's also a person that's focused on operations. And like the word DevOps has come to be conflated a little bit with this SRE function. And like I think it's worth separating these things out. The SRE takes operations to a new level of excellence that most people haven't seen or understand. They're a passionate engineer. They're focused on accomplishing one outcome. And they do that to death. They create an extraordinary level of operational maturity for one thing. And they do that for the entirety of the organization. So the idea here is you have someone who is their natural enemy is toil. Most of the SREs I know, they love drinking. Mostly they just want to sit and drink. And they know that if they have to do manual activities, they don't get to do that. They also like to fix things when they go wrong. And it's a very sort of special, it's a special flower that I've experienced in this role. But these people make such transformative change. This was what we used to do inside Google. And by doing this, you get this relentless focus on operations. You get maturity of operations. You bring a deeper operations DNA into your organization. You create specialization of operations. Now, I'm not saying everyone here has to become an SRE. That's not the case. Not every organization would necessarily want or could afford SREs. But we would certainly benefit from thinking a little bit more like SREs. And so if we think about breaking up this operations function, one of the first things you encounter is the opportunity for specialization. So if you look at the SREs and you look at the way that SREs run inside Google, you'll have infrastructure operators. These are folks that just come and rack and stack and organize the basic infrastructure and basically tie it together and replace things that are broken. And it's a relatively simple mechanical set of activities. On top of that, you'll have an operations team that is delivering the cluster operations. So you can imagine this is a team that's just producing a logical compute environment like Kubernetes on the cluster. And that gets you to a point where you have a logical compute framework where you can just have your developers write their code, drop it in, and it just works. And they never have to worry about the infrastructure. They never have to worry about provisioning their clusters. On top of that, you can also create further specializations where you can have an organization that's delivering a specific service. Like, I mean, there's probably a lot of people in this room that self-identify as full-stack engineers, which means that if you have to, you can provision, operate, and run a Cassandra cluster. Or you could, put together a Kubernetes cluster. You could do all these other things. It's great that you can do that. Oh, good Lord. I thought I'd shut this down. Okay. And we're back. My best experience in one of these presentations was I lost, I think, 10 hours of slide editing, and I don't know how it happened. I think it was a Google Docs thing. And I had a situation where it was like that. I flicked the slide over, and it was like, to do, say something smart here. It That's great. There's nothing that improves your presentation like that. So back to our story here around these operations functions. People are not generalists. You would not expect me to operate and perform surgery on someone. It would be a horrible disaster. No one would be happy at the end of it. And so if you think about the way that we've succeeded, from a societal perspective, we specialize. There's no reason why we shouldn't be more specialized around our operations. There's no reason why one development team should have to operate everything. This whole idea of full stack engineers creates problems inside organizations of scale. If you can start to take things and actually create reusable services, you're going to get a lot further in life. And so when you start thinking about the SRE value proposition, this idea of specialization becomes a real thing. They can start to deliver these common services. So they can start to actually take on the ownership of the Cassandra cluster and make sure that if you need a Cassandra cluster, it's available at the other end of the API. This starts to look like this cloud-native technology. Like, why wouldn't you provide your own services? Sure, you could use it from Amazon, but maybe you want to use your own versions of this. They create deeper opportunities to automate. If you're running a full-stack solution, the probability that you're going to have the time to automate out everything just is non-existent. You're probably not doing everything all that often. But by consolidating all this work around one person, making them do it a lot, they can get really sick of every point of friction, every point of toil. So that actually creates broader efficiencies inside the organization. And they get the organization over the learning curve for operations. They bring this DNA in. They trickle it out like people learn. This is a really good thing. And the other thing that you get out of moving in this direction of operations is far more nuanced strategies around the way that you run your operations. So you can start to do things like much more nuanced deployment strategies. You can run experiments. You can trickle a small amount of load, 1% of load for your application to a new deployment. See if the customers like it, actually measure it, roll back if you have to. All of these things become possible if you have a very high level of operational maturity. You no longer have to live in the world of fear because for a lot of organizations, they exist in this roll-forward strategy where I'm going to make a change, and then I get a certain point along the way, and then it's just roll-forwards because I have no practical way of reverting to what I was doing previously. Obviously, blue-green deployments, there's a lot of strategies you can do to avoid that. They can actually start to do things like construct recovery playbooks. Like, how many people here have the time to actually experiment with disaster in their environment? Who would, okay, there you go, there's a few, it's impressive. There's not a lot of people that would walk up to a cluster and pull a node just to see what happens. Like, well, let's figure out what happens when this happens, right? And then, like, oh, crap, things went badly. Let's figure out how to get it back. Let's write a playbook. Let's write it down. So when it's 2 a.m. and I'm groggy and I might have had a beer and I get paged, I just pull out the playbook and run it. And I don't have to deal with that. So you get an opportunity to get far more operational proficiency by doing this. And you can start to get ahead of things. If you have these expert operators who are focused on a small piece of the stack, they can start to ask questions like, okay, well, I'm monitoring these tailing indicators of what's going wrong. I know that things went sideways when my CPU utilization spiked off the charts. What are the leading indicators of that? Are there other things I can be observing? Can I actually look at the saturation and a variety of other utilization statistics across these things and try to get ahead of these activities? So now what I'm going to do is start pivoting a little bit and talking about some sort of operational design best practices. I've set the stage a little bit. We're all on the same page, hopefully, around what operations can look like, the utility of this specialized operator, some of the things that can start to happen inside your organization as you bring this. So let's talk about like grounding it and making it real. And I talked about that whole idea of the SLA optimization problem. And this is a very concrete thing that I see a lot of people do. People want to get to a certain SLA. An SLA is really a byproduct of how long does it take for something bad to happen, divided by how long from the last time something bad happened does it take to get things back up and running, right? So that gives you basically the SLA figure. People psychologically immediately jump to the idea that I want to minimize or maximize the duration between bad things happening. And they often do that at the expense of how long it's going to take me to get things back up and running if things get weird. So designing for recoverability, so not just maximizing the MTTF, but minimizing your MTTR is actually often going to give you far more upside from an operability perspective than you would otherwise think. And that has some pretty nuanced implications as you start looking at your architecture, the topology, the way that you deploy your application, and the type of system that you run your application in. And to get to a point where you have these high levels of recoverability, there's a few things you need, right? You need intrinsic diagnosability. Something bad happened. What the hell happened? Like, I don't even know where to look. That's a bad start. Having the actual structured logging, queryability around your logs, the ability to actually understand what exactly transpired and recover it is important. And a side note here, as you start looking at things like Kubernetes, Kubernetes is introducing wholly new challenges around logging and monitoring and understanding. The types of applications that are running are becoming far more intrinsically ephemeral. It's going to require new tools and new techniques to get there. And so this is something I definitely encourage people to think about. Automation is important to recoverability. Ideally, your system should just recover itself. And to get to that point, you need reproducibility, the ability to systematically reproduce and bring back into a coherent state your system is important to this metric. So let's talk about how Kubernetes operates. We were kind of, when we were starting the Kubernetes project, my friend Brennan he's a bit of a robotics nut, right? So he was a college professor. He's a sort of jack of all trades. And one of the things that he's very passionate about was robotics. And so one of the things that we started thinking about a lot, and we didn't just think about this from the Kubernetes perspective, we'd seen this inside other parts of the organization, is that control loops are extremely powerful. If you can create a decentralized, federated thing that is responsible for doing one thing and doing one thing well, it's going to create better outcomes. So if you look at the way that I use this example all the time. I used to fly a little model airplane, and I loved it. It was great. It was flying on a sports field. I was 10 or 12 years old. And then one day, it's 10,000 pieces of balsa wood across the sports field. Because I was not very good at flying a plane. There's some things operators don't do very well. Now, you look at a modern drone. That is a perfect example of control loops in action. There's a set of things that are designed to hold the drone into a coherent state. You take a piece of declarative input, you pass it to that system, and it just does what it's supposed to do. And it creates a wholly new experience. That drone looks nothing like that balsa wood plane that I smashed across the sports field. It's a wholly new system. The Kubernetes control loops, this idea of having a replica set, something that is observing and driving a set of other things into coherence, both in terms of scale, but also in terms of health, is extremely powerful. And so as you start thinking about recoverability, this leads to self-recovering systems. This leads to the ability to actually trust the system to maintain things that are running in this running state. And it's really good. Funny side note is that it actually masks bad code. Like, I've seen this, I kid you not. People come to me and they'll be like, I swear my code has got worse. Because it used to be I get paged when I went out of memory, and now everything's running in one of these pods, and the replication controller, I just have a health check, it detects it then, and it just restarts it. And I've been watching this kind of increase up over time. So it's actually interesting how, by introducing these control loops into a system, you create better aggregate SLA behavior, and then you need to just make sure that you're not running bad code as a result of that. The other thing about recoverability is this idea of reproducibility. So being able to, at the end of the day, like, how many of you think we've seen the worst cloud outage ever? All right? Now, we've seen a lot of outages where some poor soul will fat finger something, and bad stuff happens, right? Like, really bad stuff happens. What happens if there's a malicious actor embedded in an organization? Like, what mischief could they cause? And what would that outage look like, right? That's the thing I worry about, right? I don't worry about the stuff I've seen. Like, that's easy to quantify. I worry about that 5-6 standard deviation event I've never seen before. And so if you're thinking about the protection of your business, if you're thinking about how do I actually survive that 6 standard deviation magnitude 9 quake that I've heard about, I've never seen it, but I would like to be able to do this. Turns out, intrinsic recoverability, being able to actually replicate your system out, having a declarative expression of what you're trying to do, helps a lot. And so, inside Kubernetes, the entire system can be treated as a declarative framework. You just create this little YAML file, describe all of the application pieces. Every component inside your application is packaged inside a container, and you can reconstitute things at a moment's notice. Now, it isn't perfect. Like, we never meant people to interface with the YAML as a personal, human-readable tool. It really is just a simple serialization of the underlying APIs. So there's still some work to be done here. And as you sort of mature in your use of Kubernetes, you'll probably develop your own YAML wrangling strategy and templating framework and stuff like that. There's definitely stuff we need to do inside the organization to do that. You know, my company, Heptio, is actually working on a little bit of this. You can look at case on it if you're interested. But do think about this reproducibility. Obviously, it's not going to help you if your data is locked into one location. So that intersection of intrinsic data replication and replicability and then operational reproducibility is going to give you a better MTTR than you would get if you're going to have to try to reconstruct everything from scratch in a different environment. In a big way, because Kubernetes normalizes the primitives. You get this basic normalized ideal infrastructure environment that you can just take something and drop it into and run, as long as you don't have too many other service dependencies. Another best practice I see here is this idea, you know, from an operations perspective, is structured reuse and composability. If you are running a special flower of everything in your domain, you are having to operate everything in your domain. You're going to have to train yourself to debug everything in your domain. Any opportunity to create better factoring, create intrinsic reusability, and share as much as you can, not just of the underlying technology, but the operational burden across an organization, is going to create better outcomes for you. So this is really about, you know, extracting toil from your organization by supporting specialization. And this entire continuum of you know, sort of reuse and composability we can talk about. The start of this, and this is a thing that I think people don't understand very well, it's very important to internalize, is that a container is not a VM. It's actually much better than a VM. If you think about the way that people start using Docker, they look at it as a natural rip and replace alternative for VMs. I can take everything I deployed into a VM, I can repackage it in a container, and I can just run it. And that's great. It actually is pretty cool because it's portable. But the way that, you know, when we started thinking about containers inside Google, the way we used it was pretty different. It's not like that at all. We actually introduced the C groups to create better resource isolation. We started looking at, well, not we, but the broader Linux community started to look at namespace as a way to create a sort of personal Linux environment, that sort of application virtualization. But it all started with the C groups. C groups are about resource isolation. If you start to think about the use of Kubernetes, you know, in this idea where you can start piecing together containers and tearing your VM apart into these other pieces, you get to a much better place. The other thing that you can start to do is, once you've factored these things out, like torn your application apart into a variety of different pieces where the logging subsystem is not being co-deployed with the, your web serving componentry, but has access to the same underlying resources, you can then say, you know what, I'm going to promote that logging container to a reusable asset from my organization. Why should the team next to me have to run their own version of that? They can just use the version that I have. And then at some point, you can say, you know what, I'm actually going to go one step further. Rather than just, you know, passing by value, I'm going to create this opportunity to pass by reference, where I'm just going to effectively have this thing running as a little local service that can be configured, or even better, as a capital S service where I can discover it externally. So I already talked about this idea of the Kubernetes perspective on pods. I kind of got ahead of myself. I was so excited. But it is a nuanced thing. This is an important thing to consider. One of the most common sort of failure modes I think that people encounter is creating overly large and overly monolithic containers. If you're in a situation where you can create intelligent factoring, where you can actually use the pod construct, when you want to update a logging component, you don't have to do a Docker pull of the whole damn thing. You can just update that subset. It puts a lot less pressure on a lot of the adjacent systems. And it creates an opportunity where your CI/CD process can become quite effective because you're effectively late binding all of the dependencies that are managed through these control channels. The other thing that you know, Kubernetes obviously does to promote reuse is the service abstraction. The idea here is that a pod is a potentially ephemeral thing. I might deploy this. It may run for some amount of time. And it's always possible that things will go badly. So I just want to check the time. How much time do I have? Nope, that's not running. Pardon? Another 15 minutes? Thank you. So when you think about this idea of a service abstraction, Kubernetes allows you to deploy a set of pods. These are potentially ephemeral. They can be scaled up. They can be scaled down. They may fail. They may come back. To make them useful, you need to have a durably addressable endpoint that you can speak to, so that as a consumer of this technology, I'm not trying to root out one of n that is potentially ephemeral and coming up and down. I have something specific that I can address. So we introduced this idea of a service as a first-class primitive. So you're able to put a lot of pods behind these things. There's nothing stopping you running just a singleton. There's nothing stopping you, potentially over time getting to a point where we can scale to 0 and bring these things back up on activation. We just aren't there yet as a community. But the service abstraction is really powerful. And it gives you a way to handle things like discovery through DNS inside the Kubernetes environment, or a local discovery API. So it just makes it really easy to create these decoupled systems, composable, and reusable elements. The other thing that is worth mentioning is there's still a bunch of work we've got to do. We've done a pretty decent job of creating a very simple framework that enables one to discover and access another resource that's running inside this cluster environment. We haven't necessarily solved things like dynamic routing or authorization, sort of dependency injection binding type activities. There's some interesting technologies that are emerging. Linkerd is a great example. Things like Istio from Google, if you haven't heard about it, are interesting. So there's definitely some interesting opportunities here to go from a situation where you're largely on your own in terms of, once you've, the service provides a discovery and addressability mechanism, but you're on your own in terms of things like authentication, and there's a relatively simple set of capabilities there. So the next best practice that I think about a lot from an operations perspective is immutability. At the end of the day, if you are in a situation where you have a delta that exists between a pre-production and production environment, as my friend Joe Beda says, it will one day generate a bug for you. It'll be that delta will create that special gift of a production issue later. So anything you can do to remove degrees of freedom from the deployment flow, anything you can do that's going to remove those deltas will actually create better outcomes. And containers help a whole lot with this. One of the things I've never particularly felt great about with traditional configuration management software is the idea that they're doing a lot of fancy imperative stuff in a production environment. So potentially at the back end of a scaling event, you have these fancy scripts. They could be imperative. They could just be like, do this, do this, do this. Or they could be declaratively sort of executed, where you have something that's a manifest and is being manifest in that environment. But at the end of the day, what you're doing is you're running a bunch of imperative steps. You're crafting the environment. You're grabbing a bunch of stuff. You're apt-getting. You're doing all kinds of build-out activities. And those sometimes go wrong. And when they go wrong, you have a system that's in an indeterminate state. Bad stuff can happen. Containers solve this problem beautifully. Insofar as they don't get you 100% of the way there. Of course, there's always going to be some post-configuration stuff you need to do, and we'll talk a little bit about some of that. But they give you a static binary, which you can just bin copy out, and then you can run it. And it makes your life so much better from a deployment perspective. It's also intrinsically composable, as I mentioned earlier, so that gives you nice ways to start to actually factor the subsystems. These static images, I tend to think of this as just removing degrees of freedom. The sooner you can remove a degree of freedom in your flow, if you can make sure that everything in your pre-production environment is the same as your production environment from an image perspective, you're going to be in a better shape. And obviously the other thing that's nice about them is that when you're deploying a container, it's hermetically sealed. It's relatively static. It's very, very predictable. So where do I go with this from an operations perspective? Well, obviously, we love containers, use containers. But the other thing is don't fall into the temptation of treating containers like traditional machines. Immutability is good. If you have, I mean, I understand why people would say, look, I just want this one apt-get thing. I don't want to have to pull down a 2 gigabyte production blah-de-blah image to do this update. I'm going to try to do this in the production system. You're much better off thinking about factoring, deciding how to actually tease up that deployment into a set of composable packaged containers inside a pod than you are pursuing this sort of path to insanity, which is production updates outside of the configurable system. The other thing that Kubernetes does nicely is it solves for some of the stuff that doesn't exist in the container, right? So if you think about it, hey, I have a static image. I'm going to deploy it into my production environment. I'm going to deploy it into my pre-production environment. It may be the same image that I'm actually developing on my desktop, depending on how mature my CI/CD process is. But there's always going to be variants, things that are not the same. And Kubernetes tackles this with the idea of things like config maps. So basically providing a writable framework so that when a container is launched, there is a way for the container to actually establish its identity. Some of that identity may be sensitive stuff. So it could be things like key material or certificates or other things that you don't necessarily want being passed around as plain text in the wire. And so it also introduces the idea of a secret, which is a way to, is a semantically equivalent to a config map. It's just treated a little bit more securely, and in more recent releases is encrypted on in etcd. And these just show up as volumes inside your container, so you can just access it like anything else in your environment. But you've been able to now separate out the thing that you produced during your build process with the final steady state information that you need in terms of how this thing's going to be running in production to establish the production identity of it. And you've done it in a way that looks pretty coherent. It just shows up as another volume inside the container space. The other thing that, kind of looping back around to this idea of, operations best practices, and I mentioned this earlier, is the idea of being able to pursue phased deployments. So that ability to run an experiment, the ability to say, hey, I'm going to do 0 downtime updates. This is so important from an organizational perspective. Being able to de-risk change, being able to reduce the MTTR if something does happen, enables you to go faster, not just in terms of the amount of code you can get into production, but the rate at which you can get code into production. And by going faster and doing smaller changes, you ironically de-risk a lot of the work associated with these pushes. And a big part of this is just being more nuanced around how you actually get your code into production. One of the things I love about Kubernetes is that it gives you a framework where you can pretty predictably say, hey, take this and update it in a structured and intelligent way. So, a couple of examples here. Perhaps the most powerful subsystem to support this is Kubernetes Labels and Labels Selector Framework. I've had like hundreds of people draw their architectures for me. That actually sit down and try to describe their systems. CTOs, architects, individual developers, etc. And the only commonality, the only thing that was consistent is they all drew boxes and lines. That was like literally the only thing that they had in common. Every production system is different. Everyone assigns different meaning to different pieces. Everything is composed at different levels. There's no structured way to think about this aggregation. And so in many ways, one of the things I've seen is organizations try to create forced hierarchy. They try to figure out this hierarchical scheme to describe systems, and they create a relatively static framework. And that forced hierarchy is the path to madness. At the end of the day, only you know what the semantic meaning of the various systems are. Only you know what's your front-end system, what's the back-end system, where you want to draw the cut lines. Maybe some things are both. And so Kubernetes embraces this with the idea of labels. You can assign labels to pretty much anything inside the system. And it then operates on those labels as part of its day-to-day kind of operating activities. It's a very powerful pattern because it means that you assign semantic meaning to something inside the system. You decide what it means, and then the system operates based on that meaning that you provided. So, hey, I want to update the front-end system, I want to update the back-end system, whatever it is. It also means that as you start to think about what is under the control of a subsystem, you're able to go ahead and control that by just tuning the labels. So if you want to do a really fancy pattern of update, You can do that by just looking at a node inside your system and removing a label from it, and relying on the replication controller to just bring up the next rendition of the node. There's all kinds of things you can do with this that's very powerful. And so it leads to this place of much more efficient operations from an infrastructure perspective. And the same is true for, obviously, replica sets. So if you want to diagnose something that's gone badly, by just removing a label from it, the replica set will no longer consider it part of its span of control. That thing then is not going to be shot because it's unhealthy necessarily, and the replica set will see that it's gone, just spin up another one for you so that you're back in business. The other thing that Kubernetes does to make these structured deployments better is introduces a first-class job object. So job object in this case is just a way to systematize the manipulation of labels on an environment to accomplish a certain outcome, like an update outcome. So you can say, hey, do a rolling update across this thing, and the job object will take it from one state to the next state. So it gives you that kind of specialized workflow capabilities, and it simplifies it. You could argue that this could exist outside the system. This is just a convenience framework to make a lot of those operations a little bit easier. So the last couple of minutes I'm going to spend during this presentation are grounded in a couple of anti-patterns that I see in the operations space. So, we've talked a lot about, hey, this new model of operations. We've talked a little bit about how Kubernetes provides a framework that leads you to a more mature operations paradigm. And I'd like to talk a little bit about some of the things I see people doing crazy time, like just people lose their mind around these things. The first is over-federation. Remember that MTTF, MTTR discussion? People become relentlessly fixated on managing down their MTTF. They start to think about this idea of, well, if I could just stitch together a number of availability zones, or I could do this across regions, I could create a single cluster that becomes incredibly robust, not just in the face of a single machine failure, but potentially in the face of an AZ failure or a region failure. So they create a whole bunch of moving parts. So they can treat this thing as a single system, and they're able to now deploy something in it and just get swirled around, and everything's great. It's self-healing. It detects zone outages, region outages. Everything's great. It's a big foot gun. Like, what they've done is they've introduced a fantastic way to create a highly correlated failure across everything they've done, right? Over-federation, it does lead to a reduction in toil. It does lead to some powerful patterns. In some cases, a system like I just described is entirely appropriate for an organization that has a certain availability requirements. If they need 5 nines legitimately, if they're going to go out of business if they don't get it, then by all means, put in the time. But every time you do that, every time you do deep federation, you're starting to introduce some fancy things. You introduce the opportunity for correlated outages. You introduce a whole bunch of moving parts. I remember early in my career, this kind of really aided me. I was working on a clustering technology. And I won't say what company it was for, but at the end of the day, I did some back-of-the-envelope math, and this was in like the year 1999. This is a long time ago. And any customer would have been far better off just running a single server than running this clustered technology with this really interesting iSCSI backend, et cetera. The reality is the set of things we brought into the system to address dynamic failover, the failure modes they introduced were spectacular. And so, just be careful of this type of pattern and the temptation to pursue this. And then the other anti-pattern I wanted to talk about here is microlithic architectures. We talk a lot about composability. We talk a lot about functional decomposition. We talk a lot about operational specialization. One of the things that I see people do is getting a little too aggressive around the servicification or decomposition of applications. And a simple acid test is this. If you ask someone, when you want to do an update of any one piece, how many other pieces are touched? And if you hear the answer, every update requires 7 updates, you've probably missed the point, right? You're probably at a point now where you've actually got a microlithic architecture, where what you've introduced is a really gnarly coordination problem to do updates across 7 pieces rather than just updating that monolith that you previously had. And so, all is not lost, right? It's a slow path to get there, but there's going to have to be some steps that people take. You have to start thinking about versioning strategies. You want to start identifying a set of stable interfaces where you can start to tease two pieces apart. But the process of this teardown does require a decent amount of thought, and it will require a certain amount of effort to get right, but it's totally worth it in the long run. All right, I think that's it. If you want to get involved, if you haven't played with Kubernetes, by all means, go to kubernetes.io, take a look. It's a fun project. It introduces a few moving parts that will take a while to get used to, but once you've actually got over that learning curve, it really sings to most people who are into this distributed systems or operations space. If you're interested, look at the CNCF, the Cloud Native Computing Foundation. It's a foundation that we created to home the Kubernetes project. It's pretty vibrant. I think it has 88 members right now. And we're definitely interested in getting more end users engaged. It's a foundation that we've created to help shape the technology and make sure that the technology is evolving well. And we'd love to have more end user members in the foundation. If you haven't read the SRE handbook, I highly recommend it. It just introduces a lot of interesting ideas. You'll start to learn things like SLA budgeting and a few of these other concepts we've touched on. And it may or may not be up your street, but definitely do take a look if you have the time. And then if you're interested, you can always find me at CMcLuck on Twitter. I'm open to DM. Always happy to chat. Would love to hear from you. Thank you.